Okay, so example 3, 4, 5, and 6, we're going to go through this quickly. In this one, this gives us what we're going to put as an input. So I'm going to plug 2 in for x. So I'm going to get g of 2 equals negative 2 squared plus 4 times 2 plus 1. And if I solve this correctly, which if I have the book, I am going to get negative 4 plus 8 plus 1, which will give me 5. Okay, and then if I have g of t, well, this one's just going to get us negative t squared plus 4t plus 1. So notice I just plugged in the t, and then g of x plus 2. I'm actually going to plug in x plus 2 for each input. And if I do that, I'm going to get negative x squared minus 4x minus 4 plus 4x plus 8 plus 1. So what I'm going to get is these two cancel. This is going to go with this, so I'm getting negative x squared plus 5. Okay? And that would be how we do that question. Okay? You can always pause the video. I'm going to move on so we have enough time to finish all of this. Okay, piecewise function. Now, piecewise function is kind of where you take one and take another, and you have different domains. So we're actually going to talk about that briefly. Domains are input. So notice as if the input's a negative number, we're going to use this part. Okay? If the input's 0 or above, we're going to use this part. So what if we have this negative 1? Which one part do we use? We use this part. So if we plug in negative 1, we get negative 1 squared plus 1, which gives us 1 plus 1, or 2. If we plug in 0, we use the x minus 1, so 0 minus 1 gives us negative 1. And then if we plug in 1, we get 1 minus 1, or 0. Okay, so those are our solutions, okay, to negative 1, 0, okay? Okay, next part. So the next part is finding zeros. Now finding 0 is setting it so that f of x equals 0. So then you have 0 equals negative 2x plus 10. And then using algebra, we're going to get negative 10 equals negative 2x. And divided by 2, we get 5 equals x. Okay? So that is one of our zeros. Then, our second 0 is x squared plus, squared minus 5x plus 6 equals 0. Then you can factor it. So x minus 3 and x minus 2. Okay, this is just factoring. So if you don't remember factoring, that's back in algebra 1. So this would be x minus 3 equals 0, and x minus 2 equals 0. So x equals 3 or 2. And those are our answers. You could say or a comma. Both of those work. Okay, find the values. Now, it's going to follow the same principle we used with zeros. So if f of x equals g of x, we're going to get x squared plus 1 equals 3x minus x squared. So if we move everything over, we get 2x squared minus 3x plus 1. And that equals 0. So if we were to factor this, we would get 2x minus 1 and x minus 1. Okay, and if you do the math, you get x equals 1/2 or x equals 1. Okay, and you can do part B, same kind of idea. Okay, so part A is that, part B is similar, same idea, same concept. Okay, key concepts. So domain. So we need to know what a domain is of a function. Now the domain of a function is on page 47. So the domain is, let's not have this bolded, the set of all values slash inputs of the independent variable for which the function is defined. Okay, when we say defined means there is a real value for the output. Okay, that is not something that we can't solve for. Okay, so infinity or not existing doesn't count. Okay, range is the set of all values slash outputs by assumed by the dependent variable. Okay? There's more to be said. You can talk about undefined in domain. Basically, if you can't find it, it's undefined. Okay? Defined is the opposite of undefined. So if there's not a real value for our for a certain input, there's no output, that is undefined. Okay? Implied domain, basically it's an algebraic expression for the domain. It's written with either a box or a loose, comma, a loose or box. Okay. Now I'm going to explain that later. So interval notation is a way of writing our domain. It's expressing it as a set of numbers, but we'll talk about that. Okay. Finding domain and range of a function. So this is actually where we're moving to 1.5. Okay. So we're going to start on 1.5. Finding the domain and range. You basically, domain is from left, you go from left to right for domain, okay? And range follows the same pattern, okay? So let's look at domain. We're skip. Okay, domain. Okay, so the domain of a function, notice here, we start at -1. Where do we finish? So we finish at 5. So our domain is from -1 to 5. But is there a value for 5? Well, no. Okay. So here's our rule. If we have it defined at a point, that's going to be a closed thing. Okay. So on a graph, if we start at a point, let's say we finish at another, and this is open, that's going to be parentheses. Or if you go to infinity, infinity will also be opened, okay? So right here, this was 2, this was -5. So if we look at the interval, it's closed, which means it's equal to -5, and it approaches 2, so that's undefined, okay? And then if we have a line that goes from left to right, it goes from -infinity, which is open because we can't actually reach it, to infinity. So this would be -infinity to infinity. Okay, opened. This is an open parentheses. This is closed. Okay. Okay, so that's finding domain and range. So range, again, same concept. You start at the lowest point, which in this case, let's say this is -1, and our highest point, which is, let's say this is 3. Okay, is it defined at 3? Well, if these two are equal, which we can assume they are, it's defined. So our domain is -5 to 2, and our range starts at -1 and goes up to be 3. Okay? So that would be our range, okay? And you could write it like this, okay? Can you write it another way? Well, if you have another way, you can suggest it, okay? Okay, let's quickly write out the definition of vertical line test and do one example with it, okay? So, vertical line test. A set of points in a coordinate plane is a graph of y as a function of x if and only if no vertical line passes through, or sorry, line intersects the graph at more than one point. Basically, it can only, so notice with this, if we're going this way, it would intersect each point, each the line at one point. So this would be a function. Now let's think about what might not look like a function. Let's give some examples of functions. Well, technically, right, a parabola is a function, right? If it passes the vertical line test. So think of a vertical line test like this, and you just go through it, and it should pass through one point at a time. Okay? Okay, what about this? So this is going to pass the vertical line test. Well, yeah, same thing. The line will intersect our graph at one point at a time. Okay? What about this? Well, immediately you can be like, no, this isn't going to work, because right here, what happens? This vertical line intersects this graph at 2 points, okay? So that can't be a function. Okay, what about our beautiful circle? Or not a beautiful circle, but you know, what? Close enough. This shape. Is this shape a vertical function? No, because you see, it doesn't work. Okay, apologies. Just trying to get some of these marks off. Okay, I'll just do that for before next video. Okay, so we'll talk about examples. When we'll talk about next video, we will talk about zeros of functions, increasing and decreasing, and finally, relative maximum and minimum. Okay, thank you. Bye.